In this video, we're going to look at two different ways to represent probabilities. First with tree diagrams, then with Venn diagrams. So we have a person who walks to work 80% of the time, and they drive on the other days. When they take the bus, there's a 3% chance they'll be late, and when they drive, there's an 8% chance they'll be late. So we want to represent this in a tree diagram. And the reason we use a tree diagram because there's two kind of separate things happening. There's the first thing is whether or not they take a bus or they drive, and then the second is are they late or are they not late? Are they on time or are they late? And so we're going to represent this in a tree diagram. So the first branches here are going to be whether they take the bus or drive. And they told us that they take the bus 80% of the time. I'm going to switch this to decimals, so I'm going to say 0.8 here. They take the bus. Therefore, they must drive 20% of the time because that's the only other option presented to us. So one thing with tree diagrams is this value and this value, the values of any set of branches, the sum total should be 1. So in this case, yeah, we got 1. So then the next scenario we look at is if they're on time or late. So on time or late. And the probability of being on time when they take the bus is 0.97. That's 97%. And the probability they're late is 3%, so that's 0.03. Then we have to do that again, but this time for driving, so they're on time or late. Again, on time for driving is 0.92 and late is 0.08. And that is how we draw a tree diagram for this. Now they're asking us to determine the probability that the person will be late on a random day. And there are actually two scenarios of them being late. First, there's taking the bus and then being late, or they could drive and be late. So you see there's two different outcomes here, and we need to add the probabilities of those together. So the probability of taking the bus and being late is 0.8 times 0.03, because that's the probability of taking the bus and then being late. We're going to add this to the probability of driving and being late. So in this case, we're going to multiply 0.2 by 0.08. And if we multiply these and add them together, we get an answer of 0.04, which is the same as 4%. So there is a 4% chance they'll be late on any given day. This last question is a conditional probability question. So we know that they're late because it says this, given that they were late. So we know that they were late, and we want to determine what's the probability that they took the bus on that day. So this is a conditional probability. So the probability that they took the bus, given that they were late, is equal to the probability that they took the bus and they're late, divided by the probability of being late. So the probability of taking the bus and being late is 0.8 times 0.03, and we divide this by 0.04. Now the reason I got 0.04, that's from the previous question here. See, that's the probability of being late, so that's where the 0.04 comes from. So when we multiply these and divide by 0.04, we get 0.6, which is 60%. So given that we know that they were late, we know that there was a 60% chance they took the bus. So that's how we use tree diagrams to calculate probabilities and conditional probabilities. So let's move on to a Venn diagram. So Sammy asked 60 people in a school whether they liked rugby, football, and cricket, or which sports they liked. And so what we're going to do is we're going to create a Venn diagram to represent the situation. And since we have 3 circles, and none of these things are mutually exclusive, like you can like rugby and football and cricket all at the same time, you can like them all. So there's no mutually exclusive ones. So we know that there's going to be some overlapping areas here. And so if we want to draw that in a Venn diagram, we're going to draw 3 circles in this case, and we'll have areas in which they all overlap, and that will allow us to put some numbers in. My recommendation is you should always kind of start in the middle, and they give us some information. They tell us 8 people like all 3 sports. So that's 8 people here. Then let's say this is rugby, this is football, and this is cricket here, these circles. Then they tell us that there are 17 people that like rugby and football. But within that 17, it would also include these 8 people who like all 3 sports because they also like rugby and football. The statement here, 17 people like rugby and football, it doesn't say they only like rugby and football. It just says they like both. And 8 of those people also like cricket. So what we'll do is for this section here, we do 8 minus 17. And so we end up with 9 here. That's where the 9 comes from. And we do the same thing for football and cricket. That means we would have a 5 in this section. And then we do the same thing for rugby and cricket. And we have 19 people like rugby and cricket. So we know that 11 of them would go in here. Because the 8 plus 11, that's 19 people who like rugby and cricket. Now, some of those people also like football, but they're included in that group. And then lastly, we look at each sport and we see the total number of people who like it. So for football, the total number of people should be 35. But we already have a large number of those people, right? We have 17, 9 plus 8 plus 5, so minus 35. So 9 plus 8 is 17, plus 35 is 22, so there's going to be 13 people who like just football. Again, the 27 here, people who like cricket, that includes all these people already in the circle. So that includes the 24 people here. So in this section, we're only going to have 3. And then rugby, we have 30 people that like rugby. And we already have 28 here. So that means only 2 are going to like just rugby. Now the last thing we have to do is find out if there's anybody who doesn't like any of the sports. And what we're going to do for that is add up all the people in these 3 circles. And if we do that, we see we get 51, which means that if there's 60 people in total, that's going to mean there are 9 people who don't like any of the sports. Great, so that's our completed Venn diagram there. Now question B is asking us to do some calculations from here. So we're going to choose a person at random and we calculate the probability. Now in part I, we're going to calculate the probability that will like rugby but not football. So how many people in this section here like rugby but do not like football? Well, definitely these 2 people, and then these 11 people, they like rugby, they don't like football. We can't use these numbers here because they like football. So that would give us a probability of 13 out of 60. Okay, number 2 is what's the probability that this random person will like neither football or cricket. So they won't like football or cricket. And we're looking for all the people that don't like football or cricket. Well, that's only 2 groups of people here. That's these 2, people who only like rugby, and then the 9 people who don't like anything. So that's going to be 11 out of 60. The last one is, again, a conditional one, but with Venn diagrams, we can treat conditionals a little bit differently. So we know that this person likes football. So that means they're inside the football circle. And we know there's 35 people inside the football circle. And we want to see how many of these people like cricket, given that they like football. So out of the 35 people who like football, how many like cricket? Well, it's these 2 groups of people here. So it's 13 people. So this ends up being 13 out of 35. And we can leave those as fractions or write them as decimals. But that's how we use Venn diagrams to calculate probabilities.